Hello, everyone. I'm Cynthia Wenz, your host for this episode of SLB New Energy Conversations. We all know that steel is critically important for industrialization, economic growth, and for improving our standard of living. Without innovations in steel, our cars, buildings, manufacturing equipment, and infrastructure wouldn't nearly be as durable, reliable, safe, or affordable as they are today. But this industry is also emitting more greenhouse gases than at any point in its history, which is why it is embracing change. Today, we're diving into the topic of decarbonizing steel with Omar Navarro, SLB Steel Industry Director. With more than 20 years of experience in the steel industry, he is currently focusing on technology solutions to decarbonize the manufacturing of this crucial metal. Welcome, Omar. Thank you so much for joining us today. So exciting to have you here.
Thank you so much, Cynthia. Thank you for giving me the opportunity to talk about one of my passions in life, the steel industry.
It's so nice to hear your passion. I think our viewers are really going to appreciate your expertise and hearing that in your voice. Let's just start with an overview. I think when we're talking about the steel industry, could you just give us some insight on its size, economics, role, major markets?
Yes, of course, Cynthia. So we're going to start saying that everything around us in our day-to-day life is made or using steel everywhere. As you mentioned just in the beginning, everything like, for instance, very simple products like silverware, like a river or any post is made with steel. For also including more sophisticated products like cars, like medical devices, like other materials for automotive or aerospace applications. So everything is about steel. So steel is been a crucial material in the history of the humanity. For many centuries, it's been really important. But let's talk about the market. Nowadays, the market of the steel industry is about $2 trillion annually. And it's been continue growing and will continue growing. It's been forecast to grow to 2.5, $2.8 trillion in the next 5 to 10 years. Let's put an example, just to show you how important is the steel industry. Let's come back to a little bit of the history. Let's come back to about 1970s. In 1970s, everything in the world was produced in the main as a main producer by the U.S. At that point, China started to grow, and as you know, China exponential growth was between mid 1970s up to 2010s, mid 2010s. At that point, the steel industry grew from almost 500 million tons produced annually up to almost 2 billion tons produced currently. That means that China grew exponentially, being supported by the steel industry. And this is one example how the steel industry has been important in order to support the growth and the economic growth in different countries. In the next coming years, India will have the same path, and India will have the same need to be supported by the steel industry.
So, with this footprint, I can assume that the industry has an important contribution to making reducing industrial emissions.
Yes, the important thing here is, as I mentioned, China grew exponentially with the steel industry. One of the main disadvantages of the steel industry is how large is the emissions with carbon emissions in the steel industry. So nowadays, the steel industry counts for about 7 to 8% of the total industrial emissions worldwide. So following the conversation that I just, or the message that I just said, that the steel industry will continue growing in the next coming years, this is how important it is to decarbonize the steel industry, because it's not only important to support the growth of the world, but also is important nowadays to reduce the global warming, and it's important to reduce the emissions.
But with that increasing demand for steel, how can the industry decarbonize without interrupting supply? I mean, in other words, like, can we change the process without breaking it?
Let's start defining the methods of production.
Okay.
And also an important message to say at this point is there is no single solution to decarbonize the steel industry. It depends on production method, depends of natural resources, raw materials, economics, and some other things around the steel industry. So it's important saying and defining that there is no single way to reduce the steel industry. The steel industry has three main methods of production. The first one is blast furnace, that is known as BF in the steel industry. The second one is direct reduced iron, that is known as DRI. And the last one is electric arc furnace, known as EAF. So these three methods have different advantages and disadvantages in terms of processes, in terms of volume, in terms of economics, and also the emissions. The first one, the BF, is the method that produces the largest amount of emissions of the three. Just to give you an idea, the BF produces twice emissions per ton of production, meaning two times the CO2 emissions by one single ton of steel produced. The second one, the DRI, produces almost 1-to-1 ratio. And the last one, the electric arc furnace, produces a half ton of CO2 per ton of steel. This is the cleanest method of production. But also it's important to say that the EAF was developed not for environmental purposes. It was developed by economic purposes. It's the cheapest way to produce steel nowadays. So then the important thing here is, depending on the technology that you use to produce steel, is the technology that you're going to use to decarbonize each of the methods. We know that the steel industry is extremely important, and we have to guarantee the continuous supply of material through the whole time. So many technologies being developed nowadays need to consider that all the technologies need to develop with a plug-in mindset. What I said plug-in is understanding that the technology or the decarbonization solution need to be developed and installed around the existing facilities, that the installation or the integration of the decarbonization solution in the current production facilities need to be quick enough in order to avoid any disruption of the supply in the steel industry. This is really important.
So let's talk about some of those technologies. Like, tell us about some of the ones that will enable the cleaner industry.
Yes, as I mentioned, depending on the method of production, is the technology that is being used for decarbonization. By the nature of the process, the blast furnace, the BF, utilizes carbon as the main provider of energy in the process. This carbon provides the energy or enough energy in order to melt the material that is being as a raw material, that is iron ore. So this carbon is going to melt the iron ore. So by this nature of the process, the carbon can be replaced in this blast furnace. It needs to continue using carbon, so that the main technology nowadays that is going to be a perfect fit for this production method is carbon capture. Let me tell you a little bit of carbon capture. Carbon capture is a decarbonization solution that, by its name, captures the CO2 through two main mechanisms. One is chemical reaction, and there is another mechanism that is physical absorption. So depending on the solution and depending on the needs, it can be used one or the other. So it really depends on that. The second technology that is also available to decarbonize the steel industry is also hydrogen. Let me tell you a bit of hydrogen. So the second method of production, the direct reduced iron DRI, uses also iron ore as a raw material like the blast furnace. The main difference is that the temperatures in the process are not hot enough or not large enough to melt the iron ore. In the DRI process, the carbon is being used in order to reduce chemically the oxygen from the iron ore. So this carbon provides this chemical reaction to eliminate the oxygen from the iron ore and recover the iron. But with the technology for decarbonization, it can be used hydrogen in order to replace the carbon in the DRI. So meaning instead of use carbon to react with the oxygen, it will reduce with or will react with hydrogen to reduce the oxygen and then form water instead of CO2, which is extraordinary for us. But nowadays, one of the main challenges that we have is the large amount of hydrogen that is needed in the process. Just to give you an idea, one single facility in average in the world will need between 200 to 250 tons of hydrogen daily, which is an enormous amount of hydrogen. So for the DRI, as I mentioned, the carbon can be replaced by hydrogen, but there is another way to decarbonize the DRI. If you keep using carbon as the main agent to reduce the oxygen, you can, or you expect that you're going to create CO2. So that CO2 can also be captured. So carbon capture can be used, as I mentioned, first for blast furnace, as well as DRI, if the DRI continues using carbon as the reduction agent. And then the last technology for decarbonization is focus on the electric arc furnace. By definition, the electric arc furnace utilizes electricity to melt mainly recycled steel. So this recycled steel is being melted through electricity, and the way to decarbonize this process is utilizing renewable sources of electricity or clean sources of electricity. And this is the third way to support the decarbonization of the steel industry.
And so with this change, I can't imagine there's probably challenges to adopting these solutions. Talk to us about some of the hurdles to decarbonizing the industry.
Yes, of course. This is a very important topic to discuss. The main constraint that is currently in the industry, or that stops the deployment of large decarbonization projects, is economics. As you mentioned initially, steel is being used for different products, different kind of products. That means that steel requirements are not the same. And since these requirements are not the same, the different methods existing in the industry can be used in one way or the other, or with a larger amount or different amounts, depending on the market, depending on the needs of the end product. So that drives also the economics. The largest portion or the largest segment to utilize steel nowadays is for construction and infrastructure purposes. That counts more than 50% of the total amount of steel produced. There are some other applications that have a higher end quality and higher end applications that are automotive and aerospace and some other medical applications, for instance. So we can divide the steel applications in these two different segments. One is the construction and infrastructure, and the other one is the high-end applications. That drives also the economics. Pricing-wise, the construction and infrastructure is being known as a commodity application, and the price usually in this segment is lower compared with the higher-end applications or higher value applications. So with that mix of production and with that mix of markets, the steel industry usually is known as a low gross profit margin industry. For some companies that are supplying steel for commodity, the commodity segment, the gross profit margin is in single digits. And the companies that are supplying for higher end applications usually are close to 20% gross profit margin, but there is no single company that produces to 100% commodity or 100% end market. It's a mix all the time. So with that said, the main challenge for the steel industry is economics, everything about the economics, the dynamics of the pricing and so on. So understanding this, we know that for any technology or any solution to decarbonize the steel industry is going to be an additional expense or additional cost to the steel producer. So the main challenge is how technologies will support the decarbonization without increasing a lot the cost of production, or how different kind of incentive mechanisms will be developed in order to support the reduction of price. For instance, there are some government incentives. There are also some other additional incentives developed by the end applications.
And that was my next question. What's their motivation for change? Like, if cost is such a high barrier, then what's the motivation to make the change? And I think you're touching on some of those now.
Yes, the main motivation is reduce the global warming. That is what it drives everything nowadays about the decarbonization. The second thing is following my passions of the steel industry. I've seen a lot of changes in the steel industry. And one important challenge today is that the new generations are not really attract to work in the steel industry, because the steel industry usually is not as clean as some other ones. So we have to develop some ways to attract the new talents, the new generations to work in the steel industry, understanding that the steel industry will continue being important for the future. So these are two of the main reasons why the steel industry needs to be decarbonized: reducing the global warming as well as preparing the industry for the future.
What about public opinion, and what about keeping the competitiveness in the market?
That is two important points as well. The public opinion, as you know, because of the image of the steel industry, is not being accepted in a good way. So the public opinion is very important. Needs to be an industry that is clean and is environmental friendly for the world.
And so does this move to decarbonization of the steel industry make it a more competitive industry?
It does. Also understanding all the challenges of the economics. So we need to understand how the economics are being driven worldwide, and also understanding that some regions of the world have different scenarios, economic scenarios, and situations where they can produce more or less steel, and they can supply steel all around the world. So driving the decarbonization will also be a mechanism to compete against some other regions in the world.
And how do you accelerate that? If you're thinking through, like, what can be done to accelerate the industry's decarbonization?
There are two main reasons to be considered here. One is obviously developing the economic scenarios to deploy large scale projects, like, as I mentioned, some government incentives, some end applications, markets, developing the market of the end use of the steel, and also continue deploying or developing and deploying technologies that will be able not only to decarbonize the steel, but also be economically enough in order to really being deployed in a large scale. These are the two main points that we can see how we can accelerate the decarbonization of the steel industry. So this is why companies like SLB have a great opportunity to be in the market, because SLB is developing technologies and solutions and bringing those technologies and solutions to the market in order to really support the decarbonization is a really, really important point for SLB.
So who are the stars in this? Who are we seeing just shine in the breakthrough, and who would you say is just leading the forefront?
I would say different companies. I wouldn't like to say one or two. There are different regions, different companies in the world. But for instance, a company that brings to my mind with the question is a company in Europe. Is a European and Indian company named ArcelorMittal, which is one of the largest companies in the world. This company is very active in the decarbonization for many years now. They started in 2010s or something like that. So they already are developing and deploying large scale projects. For instance, there is a project in Belgium that is the largest project nowadays in the steel industry, capturing CO2 and producing ethanol for applications. But also, this company has a fund in order to develop new technologies. So this company is not only developing technologies that are nowadays, but also this company is supporting newer technologies that will come in the future. There is another company, is an Indian company named JSW, and as well as Tata Steel. These two companies are also very active developing technologies and also developing new mechanisms in order to support the steel industry. But there is an active relationship nowadays between the end market and the steel producers. End market, for instance, automotive and aerospace applications are developing the market in order to be able to support the economics for the steel industry. So the main players like steel producers as well as end users are very active to try to develop and deploy in a larger scale the steel decarbonization.
So encouraging to hear. And we hope that momentum just keeps building. This is wonderful. Omar, thank you so much.
Thank you. Thank you,
This has been really good.
It's been a pleasure.
So good to hear your wisdom, and so glad you're leading the charge.
Thank you.
Thank you to all of you listeners for joining us. Be sure to follow us to hear more from SLB's diverse team of change makers and experts in the area of energy transition. See you next time.